Welcome to our video on the Coelho 2000 podcast, where we delve into energy efficiency and sustainability. This episode, hosted by Jose Coelho, examines cooling solutions for a 1,000 kilowatts capacity, focusing on their ecological footprint. The podcast compares various cooling technologies such as open and closed towers, dry coolers, and adiabatic systems. It highlights the most efficient options for temperate climates like northern Portugal, emphasizing the importance of sustainable choices. A key focus is on minimizing energy and water consumption while balancing operational costs and environmental impacts. The podcast underscores the significance of selecting solutions like the adiabatic dry cooler with recirculation, which reduces resource use. Listeners gain practical insights into how businesses can adopt greener technologies aligned with sustainability goals. The episode discusses the long-term economic benefits of these solutions, particularly in terms of return on investment and global environmental impact. By exploring these advanced cooling technologies, the Coelho 2000 podcast provides valuable guidance for industries aiming to reduce carbon emissions. It encourages the adoption of innovative solutions that offer both ecological and economic advantages.
Welcome to the Deep Dive, where we try to make sense of it all. Today, we're diving into something that might seem, well, a little dry at first: industrial cooling.
But trust me, it's way more interesting than it sounds. We're actually going to break down a report that compares different cooling systems for, get this, a facility in Portugal.
Yeah, Portugal. Not exactly the first place that comes to mind when you think about, keeping things cool.
Right, but that's what makes this so interesting.
Exactly. So picture this. Sunny Portugal, this facility that needs to stay cool all year round, and it's got this massive heat load, 1,000 kilowatts, like 1,000 microwaves running at once.
And to make it even more interesting, this report doesn't just say, here's how you cool it. They analyze 5 different systems.
It's like a cooling showdown. And we're talking energy efficiency, water usage, the whole sustainability shebang. Because, let's face it, nobody wants a cooling system that's basically a giant energy hog.
And that's what this report really gets into. It's not just about keeping things from melting, it's about doing it in a way that makes sense environmentally and economically.
Right. It's all connected. So let's meet our contenders, shall we? First up, the old, reliable, the open circuit cooling tower.
The classic. You've probably seen pictures, big tower, fan on top.
Like those giant things you see in, industrial areas?
Exactly. So the way it works is water circulates inside while that fan draws air across it, causing some of the water to evaporate. And it's that evaporation that cools things down.
Basic physics, right. Water evaporates, takes heat with it.
Exactly. But as the report points out, there's a bit of a catch with this method.
I'm guessing it's not exactly the most water-efficient option out there?
You got it. They can use a lot of water, especially in a place like Portugal that, can get pretty hot and dry. So the report really digs into those water consumption numbers.
Which leads us nicely to contender number 2, trying to address that very issue, the closed-circuit cooling tower.
This one's all about keeping our water contained. Instead of exposing the water directly to the air like the open system, this one keeps it circulating in a closed loop.
So less evaporation, less water use.
Exactly. And they still manage to transfer the heat away just through a heat exchanger instead of direct evaporation.
Clever, right? But what I find really interesting is how specific this report gets. It's not just closed circuit good, open circuit bad. They actually look at the different heat transfer fluids used in these closed systems.
Exactly. Like, they talk about glycol mixtures, which can be more efficient than plain water in terms of heat transfer.
Oh, interesting. I didn't know that.
Yeah, they go into the pros and cons of each. Glycol, for example, has a higher heat capacity, but then you've got to think about things like corrosion and, how environmentally friendly it is to dispose of.
So it's a trade-off. More efficient, but potentially more complications down the line.
Exactly. Every system has its quirks. And that brings us to contender number 3, which tries to sidestep those water worries altogether, the dry cooler.
Dry cooler. Pretty self-explanatory, right? No water involved.
Pretty much. It's all about using air to carry that heat away.
So like a giant fan blowing on a radiator.
Basically, you've got these finned tubes with hot water running through them, and the fans force air over those fins to dissipate the heat.
So no water use, no evaporation worries. Sounds pretty good so far.
It does, especially in terms of water conservation.
But there's always a but, right?
Especially in a showdown like this. So what's the catch with the dry coolers?
Well, their efficiency is very dependent on the air temperature. So if the air around the cooler is already hot, it's not going to cool things down as effectively.
Which brings us back to Portugal and those hot summers we talked about.
Exactly. And that can lead to higher energy consumption to keep those fans running at full blast.
And then we're back to square one, potentially negating those water savings with a bigger energy bill. Exactly. It's all about finding that balance. And that's where our next two contenders come in the hybrid systems. First, we've got the adiabatic dry cooler, which tries to bridge that gap between water efficiency and cooling power.
Okay, gotta admit, adiabatic always throws me off a bit. Can you break that down for us?
Sure. It sounds fancy, but it's actually pretty simple. Basically, adiabatic means a process where there's no heat transfer with the surrounding environment. So an adiabatic dry cooler is basically a dry cooler, but with a little extra something.
And that something involves water, right? I remember reading something about a water mist.
You got it. When the air temperature rises and that dry cooling alone isn't cutting it, the adiabatic cooler kicks in with this fine mist of water sprayed over those hot surfaces.
Ah, I see. So it's like a backup system that only kicks in when things get really toasty.
Precisely. It uses a small amount of water, only when needed, to give that cooling efficiency an extra boost.
Smart. Okay, so that's the adiabatic dry cooler. And now for our final contender, the one with the impressive name, the adiabatic dry cooler with recirculation.
This one takes the water saving to, like, the next level.
So it's like the adiabatic dry cooler, but even more eco-friendly.
Exactly. It still has that water mist system, but then it captures any water that doesn't evaporate and recirculates it back through the system.
So minimal water waste.
Exactly. Which, as you can imagine, is a big deal in areas concerned about water use.
Makes sense. Okay, so we've got our contenders lined up, everything from the old reliable to the high-tech hybrid. But remember, this isn't just a theoretical exercise. We're talking about a real facility in a real place with a real climate.
Yeah.
And that's where things get even more interesting. So we've got our cooling contestants all lined up, but now it's time to throw in what you might call a plot twist, the actual climate data for Porto, Portugal. Because Portugal, well, it's not exactly a desert, but...
It's not exactly known for its Arctic blasts either.
Right. And this report, thankfully, doesn't just say Portugal is warm. They give us the nitty-gritty, the monthly averages for temperature and humidity.
Which is crucial, because that humidity is a game changer when it comes to cooling system performance.
Huge. And spoiler, Porto's weather is, well, let's just say it's not boring.
Not at all.
Yeah.
You've got mild, humid winters. Think average temperatures around 10 degrees Celsius, 50 Fahrenheit for anyone listening who prefers that scale.
But then summer rolls around and things heat up.
Oh, yeah. Average highs pushing the low 20s Celsius, that's over 70 Fahrenheit. And the real kicker is that humidity, it sticks around all year, often over 70%.
Which, for our cooling contenders, is a big deal, right?
Huge deal. For starters, it throws a wrench into those systems that rely on evaporation. I'm talking about our friend, the open circuit cooling tower.
Right, because if the air is already full of moisture.
Exactly. High humidity means that water in the tower doesn't evaporate as easily. And if it's not evaporating, it's not taking as much heat with it.
It's like trying to, I don't know, air dry your laundry in a rainforest. That's super effective.
Perfect analogy. And it gets worse. Those open systems, all that moisture hanging around, they become breeding grounds for, well, not so great stuff.
Algae, bacteria, the works.
You got it. Which means more maintenance, more chemicals for water treatment. And the report actually puts a number on that. For an open circuit tower in this scenario, you're looking at, get this, 10 to 20,000 euros per year just for water treatment.
Okay, yeah, that's not nothing.
Not at all. Those hidden costs can really sneak up on you if you're just comparing the upfront price tag of these systems.
So what about our other water-based contender, the closed circuit? How does it handle the humidity and the gunk?
Well, being a closed loop definitely helps. Less exposure to the elements means less chance of contamination. So lower treatment costs, the report estimates about half of what you'd spend on an open system.
Better, but still something to keep in mind. But if humidity makes evaporation less effective, are closed-circuit systems even that much better in a place like Porto?
That's where it gets interesting, right? Because, yes, they use less water overall, but they still use water, which is where those dry coolers, our no water needed option, start to look pretty appealing.
Right. No water, no worries about humidity, making it harder to cool things down, no need for all those chemicals and constant cleaning.
Exactly. However, and you knew there was going to be a however, their efficiency is really tied to the air temperature. When it's hot out, Those dry coolers have to work overtime, meaning higher energy use. Those fans need more juice to push all that hot air around.
And in a place like Portugal, which is, making big strides in renewable energy, that energy source is a big deal.
Exactly. If your facility's running on solar power, the higher energy use of a dry cooler might not be as much of a concern, at least from a carbon footprint perspective, compared to a facility that's, say, powered by coal.
It's all connected, isn't it?
Yeah.
The source of the energy matters just as much as how much energy you're using.
100%. And that's where, in my opinion, these hybrid systems, the ones that try to balance water use and energy efficiency, get really interesting.
Right, because those adiabatic dry coolers, with their water mist backup system, they might be able to find a sweet spot, especially with those hot, humid summers.
Precisely. It's about strategic water use. Give that system a little extra oomph when it needs it so you're not constantly running those energy-intensive fans at full blast.
And then we have our super eco-friendly option, the adiabatic dry cooler with recirculation, which is basically like
the ultimate water saver.
Exactly. And in a region where water stress is a concern, every little bit counts. Right.
Absolutely. The report emphasizes that even small reductions in water consumption can have a ripple effect.
So we've gone from the basics of how these systems work to factoring in climate, maintenance, water treatment costs, even the bigger picture of energy sources.
Yeah.
But there's, I'm guessing, another layer to this whole environmental impact puzzle, isn't there?
Oh, absolutely. We've talked about water use, energy use, but there's a whole other side to this, the environmental impact that goes beyond those direct inputs.
We've really gotten into the weeds on these cooling systems. Now let's talk about those less obvious environmental impacts, those hidden costs.
It's easy to get caught up in the water use, the energy use, but the environmental impact goes way beyond that.
Right, because even something like, cleaning a cooling tower, that has environmental consequences, right?
Exactly. Remember those water treatment costs we talked about? For both open and closed circuit systems? Well, those chemicals used to prevent all that gunk from building up. They don't just magically disappear.
Right, they got to go somewhere.
Exactly. The report actually highlights that even after treatment, there's potential for environmental harm from those chemicals. It's a reminder that the cost of a system goes way beyond what you see on your energy bill.
Okay, so even though those dry coolers might seem energy hungry, their minimal chemical use could actually give them an edge in the long run, environmentally speaking.
That's a really good point. It's about looking at the whole picture, the entire life cycle of the system, not just one piece of the puzzle. Right, like a holistic view.
Exactly.
Yeah.
And on that note, another piece of the puzzle, carbon emissions.
Yes, the big one.
Because whether it's the electricity guzzling fans or the energy used to treat all that water, it all adds up.
It all leaves a mark.
And this is where, again, understanding Portugal's energy situation is so important. They've been really pushing renewable energy, especially solar.
Right, trying to move away from fossil fuels.
Exactly. So the carbon footprint of a cooling system in a solar-powered facility in Portugal is going to look very different from one that's powered by, say, coal.
It all comes back to context.
Always. Choosing a cooling system isn't this isolated decision. It's tied to the bigger picture of energy infrastructure, of a region's commitment to sustainability.
It's all connected. So after all this analysis, all these factors, what's the final word from the report? Who wins the cooling showdown? Well, they ultimately land on the adiabatic dry cooler, with recirculation as the most sustainable option for this particular situation in Portugal.
Which, after everything we've talked about, makes a lot of sense. It minimizes water use, has that extra cooling boost when it needs it, and avoids those heavy chemical treatments.
Plus, with Portugal's focus on renewable energy, that slightly higher energy use from those fans is less of a concern.
Right. Context is key.
Always. And to be fair, the report does make it clear that this isn't a one-size-fits-all declaration. The best system for, I don't know, your factory, your specific situation, it's going to depend on so many factors.
It's about your climate, your budget, what kind of energy you have access to.
Exactly. It's about asking the right questions, thinking critically about those trade-offs.
Which is, I think, a good takeaway from any deep dive.
I agree. It's easy to get overwhelmed by all the information out there, all the options.
Right.
But if we can slow down, think critically, ask the right questions, well, then we can start making more informed decisions.
And that's what it's all about, right?
Exactly.
Well, on that note, that wraps up our deep dive into the surprisingly complex world of industrial cooling. We hope you learned a thing or two, or at least have a newfound appreciation for those giant cooling towers you might see around town.
And who knows, maybe the next time you feel a blast of AC, you'll think of us.
And all those complex systems working behind the scenes to keep things cool. Thanks for joining us. And until next time, stay curious.